Hi guys, now what I'd like to do today is go over this first question on the exam style questions to answer. Okay, so first of all what we need to do is when we're going about doing these we need to think about highlighting key points on every question. Okay, we call it prepping the question. So figure 1 shows a circuit symbol for different components. Which component is a variable resistor? So what I'm doing is highlighting the fact that I said variable resistor, and then we're going to choose what that one is. So the variable resistor, now all resistors have these rectangles in them, so these are all resistors. Okay, so the rectangle shows resistor, and I want this one with light coming in, that is a light dependent resistor, so this is an LDR. This one is a thermistor, like you might have in a thermostat. And this is the one which we're saying is the variable resistor. Okay, then it says which component is the thermistor. Well, we've already looked through that, so we're saying C, just double checking. So we're going to highlight again, so we're just going to double check because we need to make sure we don't make a silly mistake. So a thermistor, now I've written on them which I thought was a thermistor, so I'm choosing C. And then finally it says which component will the resistance decrease when the temperature increases. So again, that's thinking about, so if I go over to here and the resistance decrease with temperature, now the one that involves temperature, I'm just going to prep my question. Temperature, okay, is my thermistor. And I look back, my thermistor is C, so it's C. Okay, so that's my that's the first couple of questions done there. Then we're going to move on to in which component is resistance decrease when the light intensity increases. So if we go back over here, the light dependent resistor. Okay, so if we quickly prep our question, so light intensity, so resistance with light intensity, we know the resistance changing with light intensity must be LDR, and we'll just quickly flip back again. LDR is B there, look, so LDR is B. And then it shows our next thing is figure 2. This is figure 2, so making sure we're focusing on figure 2. Figure 2 shows 4 different arrangements of resistors. 2 of the arrangements are in series, 2 of them in parallel. So describe the difference between a series and parallel arrangement. Okay, so series, parallel. So we should say that a series has only one loop. Okay, series has only one loop or branch. And we can also say that a parallel circuit has more than one branch. Has more than one branch. Okay, so that's the difference between those two, and that's enough to get us our marks. Okay, that'll be 2 marks, 1 for each. The next question says, which arrangement has the resistance of 10 ohms? Which arrangement has a resistance of 10 ohms? Okay, now 10 ohms is going to be this one because in a series circuit we add them up. Okay, in a series circuit it's 5 ohms plus 5 ohms, which equals R. Okay, so we should, oh, that's 10 ohms. Okay, so that's 10 ohms. So we go back here. We're saying that R is the correct answer for here. And the next one, which arrangement has the highest resistance? So what we've got to do is go back through and find out where it might be the highest. Okay, now in parallel, remembering parallel, we the branches are the same. Okay, and they don't add up, so it's lower than the lowest resistor. Okay, so that's lower than 10, that's lower than 5. Okay, well, so this one must be 10 plus 10. Okay, so this is 10 plus 10, which equals 20 ohms. We've already worked out that 10 ohms. This one is less than 10, lower than the lowest, less than 10. This one is less than 5 ohms. So the answer must be P in this case, because 20 ohms is the largest. So we can say that that is P. And then last question on there, the students connect a resistor to the cell for 60 seconds. Okay, so we're gonna highlight the fact that it's 60 seconds there. The current through the resistor, okay, that's important. Current through the resistor is 0.97A. Calculate the charge flow. Okay, now we've got actually been given the equation here. It is Q equals IT. Okay, IT, Q equals IT. We've got that. I is A. Okay, knowing that current is that there. Okay, and the time is got to be worked out in seconds. The time in seconds is 60 seconds. So give your answer to 2 significant figures. That is key there, because our answer, if it's not done to 2, won't be right. So what we need to do is we're going to write I. Oh, okay, I equals 0.97 amps. Okay, T equals 60 seconds. Q equals 60 times 0.97, which equals, okay, 58.2. However, we've got to remember that we have been asked here to give it in 2 significant figures. So this is the correct answer, but for 2 significant figures, we have to do 1, 2, and then round this one. And if it's 0.5, if it's below 0.5, it's that round down to the 58. So our answer is 58C. Okay.